Good day, everyone. My name is Ravi. I work for a peace app in Canada. So, our vacation plan for the 2020 included a visit to the lovely country of Iceland or to New Zealand, but unfortunately, it got postponed to 2021, if you are lucky. So, I have been cooped up at my home instead, watching the old shows like Monk and the New Drinks just to pass the time when I am on my staycation. Meanwhile, I wanted to do something useful uh, just to take the NENA emergency number professional exam, and I thought I'll get some studying done during this time. When I was doing that, I thought, why can't I share some of the content I have got so far? I have been working on and create some few videos and share it with the others. So here it is. I do not claim that the content used in these presentations are 100% of my own. For the studies, I used the ENP booklet, other NENA standard documentations, as well as the NENA information documents and contents available elsewhere in the internet, various telecom books, as well as my own experience in the industry. You can watch these videos for whatever reason you want, either prepare for the test or even just to understand how the 911 works basically. If there are any errors in the content, do let me know. I will correct them and post it in a new and updated video. Finally, these videos are intended to be supplementary to whatever the documentation is available at NENA for your preparation. By themselves, these videos will not be adequate to take the exam. I want to make that clear. So if you have any questions or comments, post it here or search for Ravi Valamandan in LinkedIn and send me a message and I will respond. With that, let's get started. The first video is about telecom terminology, the most common terms used in the basic telephony that we need to know. These terms will be used repetitively in the subsequent videos. First of these is LATA. The origin of LATA goes back to 1984 when the US Justice Department broke up the erstwhile Bell system, which essentially had monopoly for the phone services across the all 50 states in the USA. That was broken into multiple regional telephone companies. So during that process, they defined what is called the LATA, which is essentially a market area that a local company manages. In this image of California, for example, both Los Angeles and the Oxnard here are in the same LATA of 730. 730. So any call made between these two cities, Los Angeles and Oxnard, is considered a local call. But San Diego here is in LATA 732, and if a call is made between Los Angeles and San Diego, it will be a toll call. But it has been over 35 years and a lot has changed since 1984. There is not much revenue in long distance calling for the telephony providers, uh, either within the country or even internationally. But things do change very slowly in the telephony regulation front. And so this is how it will stay in the near future. So what exactly is LATA? LATA is local access and transport area in a specific geographic region set up to differentiate between local and long distance calling within the USA. The PSTN or the PST is made of local exchange carriers called LECs and inter exchange carriers, either IECs or IXCs that are governed by the LATA boundaries. The telephone calls between parties within a LATA or intra-LATA are handled by the local telephone companies and they are under the jurisdiction of the state public utility commission. On the other hand, calls between letters or inter-letter calls are handled by the inter-exchange carriers or long-distance providers and are governed by the FCC. Even if you have a, let's say, landline contract with AT&T, you can have a long-distance provider, somebody else, whoever cheaper, either Vonage or Primus, or or anybody like that. So you will get two bills, one for the local telephone bill and another bill from the your long distance provider. Or they may be consolidated single bill because one carrier may charge the other, things like that. Um, yeah, so the inter-exchange carriers are governed by the FCC in Washington. The calls made between the latter are local calls, and the calls made within the same later or local calls, and the calls made between later can be toll calls. In Canada, though, later does not really have any legal significance. As of 2000, the entire country of Canada belonged to the same later of 888. But Canada does have the local interconnection regions for the long distance billing, and these LIRs are much smaller than later. Typically, they cover a town or city. For example, Airdrie is just about 20-25 kilometers from Calgary. But whenever we make a call from Calgary to Airdrie, it is considered a toll call. And depending on the package you have with your telephony provider, you may be charged as a long distance call. So the next is local loop. So the doodle diagram I put together here essentially shows the elements necessary that connecting your phone at your home to the local exchange carrier or the local switch in the telephony office. So the phone is connected using a pair of copper wires into the splitter box you have in your basement, and that get carried by the telephony poles into what is called the local distribution frame in one of the pedestal in the street, and from then it goes to the main distribution frame within the end office. I'll tell you what end office means shortly. Into the end office, and it goes to the local telephony switch for the making telephony calls, and it may goes to the DSLAM for the internet. So the internet connection is shared using the same pipe, so to speak, using an ADSL modem, which goes to the same splitter and then across. The wiring between your phone or between your phone to the switch here is called the local loop. This copper wire is basically a couple of wires. One carries the current and the other carries the return signal. So as a customer, as a telephone customer or subscriber, you are responsible for the wiring from your device through your drywall into the splitter. This is the demarcation point for the telephone companies, and they will be responsible for the from the splitter onto their network. But this entire portion from the device to the switch or the DSLAM is called the local loop. So the architecture previously shown in the slide, what's called the POTS architecture, yes, essentially, at least on the local loop side, is stayed the same for hundreds of years, or just 130 years or so. And as of 2020, only about 39% of the household in the US have that POTS lines, POTS. It's POTS stands for the plain old telephony system. In Alberta, where I live, as per the statistics from 2017, only 55% of the household had the landlines. From what I looked at it, it it appears that about 5% of the households in Alberta, there's a decline on whoever is having the landlines. So I expect if the trend continue, the percentage of the household who will have landlines in 2021 will be around 45%. Also note that the landline service can be delivered as a fixed VoIP service, specifically from a cable provider in Canada, like Shaw or from Comcast and Cablevision in the States. That may be a fixed VoIP service, and it can be delivered either using a cable modem or even using fiber. And and of course, the fixed VoIP service essentially means that if you move the device, your cable modem from your home to somewhere else, it should stop working. There is a significance to the way the fixed device versus nomadic VoIP service in terms of the 911 calling. There is a significant difference. I will talk about that in a subsequent video. The nomadic VoIP carriers like Primus or Vonage, basically they provide, and TechSavvy in Canada, they provide a cheaper option for the landline calling. They provide the service using the internet. So as I mentioned, the local loop is the access circuit that carries the phone traffic between the house to the local exchange. In most deployment, it is an unshielded twisted pair of copper wires. One carries the signal and the other carries the return signal. Most commonly, the terminology or the contemporary meaning of the word is that any circuit that connects the customer premises to the edge of the telco network, it could be a fiber optic cable or the UTP copper cables or even a radio link. So the next is the central office. Uh, the, cen- uh, the central office is the local telephone company's switching center. Um, there are two types of central offices, or the world telco people call it COs. The first is called an end office, or the local exchange, which provides a dial tone to the customer home. It connects directly to the outside plant and it kind of distribution system to the homes and offices. The second type of central office is called the tandem office, which essentially carries the toll traffic. The end office is also called a class 5 office, and it provides the customer services like a dial tone or call waiting or call forwarding, essentially the telephony features you have on your landline. Um, Apart from a proper end office, as I mentioned before, due to the decline of the residential phone services or number of the subscribers having the residential phone service, carriers are moved away from a full-fledged central office to what is called the remote offices, a kind of scaled down central office. The difference is that um, if the connectivity between the smaller remote office and the central office goes away, apart from the dial tone, uh, the people who are connected to the remote office will not be able to access any services like 911 services. That problem need to be fixed before they will be able to dial out for emergency calls. So that has been the trend at least in the States and Canada for a while now. Um, so the tandem office is also called a toll office or a class 4 office. Um, It the difference is that it does not connect directly to the customers. It provides the toll services or the long distance calling or connectivity from any one central office to another central office. That's what it does. So it also creates the billing records or the toll call records, and that will be handled by the tandem offices. Most telecom providers use a dedicated class 4 switch for handling the 911 calls. They are called E911 tandems. In the E911 network, the terminology will occur again and again. They will have a dedicated switch to handle the 911 calls. that actually connect to the multiple end offices, so to speak. The next term is line. The word line actually refers a couple of things. It could refer to the physical local loop connection from the telco switch to the telephone or the computer at the customer premises. In more general terms, though, it can refer to a residential phone line, for example, or a business line, or a multi-line set, uh, or a common control unit of a key telephone system. So essentially, anything that faces towards the customer, it could be a line. A line, in its purest definition, supports a single phone conversation. It carries both sides from party A to party B and party B to party A. It has common phone features like call forwarding or caller ID and caller waiting, etc. attached to it. Yeah, a typical residential line will have a 10-digit phone number attached with it, at least in most of Canada. In some smaller cities, it could be a 7-digit line as well. And this is a number that is presented to the 911 call taker when a user having that line calls 911. That's a number that will be visible as a callback number to the 911 call taker in the PSAPs. So as opposed to a line, which is essentially the connectivity from the customer home to the central office, a trunk connects two telephone switches or two end offices or two central offices, so to speak. Uh, the trunk can be shared between multiple users and usually sized based on the expected traffic. Let's say the one central office have 100,000 customer, another central office has another 100,000 customer. Not everybody will be making or receiving telephone calls at the same time. Based on the Erlang engineering, etc. Typically, even during peak hours in early 2000, when most of the people used the landline phones, or even later 1990s, less than 10%. Usually, it is only about 5 or 6% of the people provision in the switches will be making calls between them. So if you are talking about 200,000 person, the trunks um, between those two end offices will be only around 20,000 or even much less than that, depending on the type of customer and type of traffic we expect between the end offices. There are several type of trunks. For example, if you have a private branch exchange in a government office or in a business, you'll be using a PRI trunk or a SIP trunk to connect to the telephony provider, or it can connect to end offices or an end office to the tandem office, or it could connect to a telephone provider. For example, between AT&T and Verizon, previously they used what is called the SS7 trunks, and most of the telephone providers use what's called the SIP trunks, or similar between Shaw and Telus here in Canada or Alberta. Yeah, as I mentioned, till 2010, the telephony providers are connected using circuit switch trunks called SS7 or signaling system 7, but these are slowly being replaced by IP trunks using SIP or the session initiation protocol. I believe US is way ahead of Canada in this. Most of the inter-carrier traffic is using the IP network in the States, as I understand it. If you're in the telephony industry, you will be hearing the term soft switch again and again. So these are specialized. Uh, uh, these are, I don't know, maybe about 20 years older terminology. So prior to 2000, the specialized hardware systems are manufactured either by Nortel or companies like that, occupied like big rooms or even big buildings. Those were used for, I don't know, 20, 30 years. They were slowly getting replaced starting about 2005, 2006 by software-based servers uh, called soft switches. They were manufactured originally by Nortel and later Genband or Nokia Siemens or Metaswitch and Ericsson, those companies like that. And they are much cheaper and flexible to deploy. They can have frequent software updates since they are basically software driven, and they occupy much lower footprint. So this is one of the older model switches in the 1980s. They occupied rows and rows of larger room. This entire thing in 2000 by 2010s, I think this is one is from the company called Metaswitch, and this is from the X Nortel slash Genband slash Ribbon Networks. These maybe I don't know, maybe 2.5 feet by 3 feet long. So these kind of switches can support 200 or 250,000 customers. So this is much lower footprint. So um, for example, a soft switch like this, I believe Calgary today have maybe around 300,000 households. The entire province of Alberta can be supported by just a couple of these soft switches. And finally, MLTS. MLTS is the multi-line telephone systems uh, uh, that are used in the enterprises, businesses, and government offices and large call centers. FCC recently changed the terminology that was used for by the MLTS and called them ECS, Enterprise Communication System, but they are basically the same thing. Um, these MLTS systems provide telephony services such as inbound and outbound calling for a large number of users in a government office or on a large enterprise, even hundreds or even thousands of the users, with only a smaller portion of the telephone lines. If we have 100 users, maybe 10 or 15 telephone lines are adequate because not everybody will be making or receiving calls, unless of course it is a call center where most of the people will be answering the calls all the time. But in a typical enterprise, that will not be the case. So if you have thousands of customers, maybe 50 or 60, depending on the nature of business, should be adequate. And it could be premise based, like a PBX, private branch exchange, or it could be hosted the old fashioned Centrex or the newer hosted PBX systems. It could be analog or digital like a PRI, or it could be IP based, which is essentially a SIP trunk based system. It is very rare in those kind of deployments. uh, let's say there are hundreds of users in enterprise. Not every phone will have a 10-digit dialable number. uh, Most of the deployments will have only extension number if they call within the enterprise, fronted by a common outbound caller ID. So if you make an outbound call, it will be the common ID of the company or enterprise that will be presented to the to the call taker. So the problem here, though, a PBX could serve the telephone or users behind multiple buildings. They may be in a different state or even different cities in some cases. For example, when the caller ID or the telephone number registered to the telephone company that is being presented, if it shows an address in Calgary, but the call in theory could have been made by somebody in Vancouver, so to speak. So that will be that's the challenge PSOPs are facing today. Um, those things hopefully will be addressed by couple of laws that came into effect in the February 2020. There is a Caris law, which and the Ray-Baum law. Ray-Baum is not law; it's something else. We'll talk about in much detail later. So these these in this PBX system, if a user is using a telephone line, they may need to use a dialable number, like for example 9, to seize an outbound truck and make the call out. So if you want to dial 911, for example, most of the PBXs do not support you dialing directly 911. You have to dial 9 first and then 911. Unfortunately, in deployment like a hotel, this actually caused a problem, and Carey's law essentially states that even if you are behind a PBX, if it's a newer PBX that is deployed after February 20, or if the PBX is going through a software upgrade, you have to enable the functionality so that a call can be made by directly dialing 911. Ray-Baum's law, that's Carey's law. The Ray-Baum's law addresses the what's called the dispatchable address portion of the portion of the phones. If there are let's say 100 telephones behind a PBX, each of those phones should have a proper address. Let's say a building in Calgary serving a user in the fourth floor, it should specifically say the call had been made at the desk C143 in the fourth floor of the building located in a specific address. That will help a 911 call taker immensely, so that instead of in case if the caller is not able to speak for whatever reason, they will have the proper address and they can dispatch help immediately. That's the intent behind the Ray-Baum law, but we'll review the exact contents in the later videos. For now, I thank you very much for watching and staying with me.